So we have gone from how the muscle contracts and all the anatomy involved with that. So let's look at muscle tension now, all right? Because we know the contraction process. It's an all or none event. But let's see little parts and pieces of this whole concept of a skeletal muscle contraction. When we talk about skeletal muscle contraction, we have to first talk about muscle tension, because it's the tension is what happens when all of those myofilaments, all those little bitty parts and pieces, actin and myosin, start interacting with one another, okay? So muscle tension is just the force generated when a muscle contracts. That's it, okay? And again, that's the interaction between actin and myosin. We can measure this. We can see it when we are in a lab. And you can graph it. You can see, you can put electrodes on either end of the specimen there. You can excite it. You can witness period of contraction, and you can witness the period of relaxation on what's called a myogram when you graph it out. The thing to remember, though, is that muscle tension is looking at the whole muscle. Right? When we look at this in a lab setting, we are looking at an individual muscle twitch. Why does that matter? A muscle twitch is never seen in the real world. A muscle twitch is only seen in a lab. But I can use what I'm witnessing and recording and measuring in a lab, the twitch, and apply it to the whole dang muscle itself. There's never one twitch that will cause the biceps to contract, the deltoid to contract. It is a collection of twitches. It's a collection of all those myofilaments, muscle fibers contracting to cause the whole muscle to move. If you have a muscle belly full of 100,000 muscle fibers, one fiber is not going to be enough to get the whole muscle to move. So when we look at this muscle twitch from that picture there, we had three parts to it: the latent period, the contraction period, and the relaxation period. To get this thing to go, because remember, muscle contraction is all or none, okay? We have to reach that minimum threshold. Once we reach that minimum threshold, this thing is going to happen. This contraction is going to happen. Latent period, contraction period, and relaxation period. The latent period, there's no change in tension, okay? Time after stimulus, but before contraction begins. So let me go back over here. There's the stimulus. And you can see it's not a very huge amount of time. Okay? But remember, I mean, we got to take this. It's got to go from the sarcolemma down the T-tubule. It's got to trigger calcium voltage gated channels, open up sarcoplasmic reticulum, terminal cisternae. That takes a few milliseconds. And that's what that latent period is. Then we have the period of contraction. All right. Calcium's been released. Now, in this contraction period, this is where the power stroke happens. Okay. The interaction between actin and myosin. All right. So calcium's filled that sarcoplasm. Calcium is bound to troponin. Cause tropomyosin to move. Actin and myosin are interacting. Relaxation period. This is when the stimulus has ceased, obviously. This is when sodium voltage gated channels have closed across the surface of that sarcolemma, and potassium channels have opened now. Potassium voltage gated channels have opened now. Stimulus down the T-tubule is no longer there. That triggers calcium to be re-upped back into the sarcoplasmic reticulum and cisterna. Calcium removes itself from troponin, which causes tropomyosin to move back into its original position, kicking those myosin heads out, causing relaxation. And again, there it is, contraction, and then a slightly slower descent back down to relaxation, to resting. Okay, so if that's an individual muscle twitch, and you just said, Dr. T, that that muscle twitch is seen in a lab, yes. If you do see it in the real world, that means you have there's some kind of neurological event going on, right? There's some damage going on, so you don't see it normal, all right? But if you do, that's bad. All right, so let's apply this to the whole muscle itself, because again, I said that a muscle twitch isn't enough to get the whole muscle to fire and move, contract. All right, so let's look at it from a bigger aspect. All right, let's look at it from a bigger aspect. Motor units. When a nerve stimulus, when that action potential, when that nerve stimulus comes down, that nerve impulse comes down the motor axon, it goes and supplies a specific group of muscle fibers. And that is what we refer to as its motor unit. Right? So if we engage a significant number of motor units, i.e., a significant amount of muscle fibers, the muscle is going to contract. This is referred to as motor unit recruitment or motor unit summation. Okay? Summation just means to add. We are adding more and more motor units being stimulated within that muscle. We are recruiting, we are calling upon more and more muscle fibers then. The more muscle fibers, the greater the contraction, the longer the contraction, right? As you can kind of see here, up here, here's our muscle tension, all right? And here's the voltage, okay? You can see I've had a stimulus, it opened up, you see there's nothing here, right? Nothing, nothing. And you see here, there's my stimulus, okay? There's my contraction and there's my relaxation right there, all right? As I've contracted, I've engaged a couple motor units, okay? Motor unit 1, right there, has been recruited. We always recruit small motor units first. This is what allows us, this is what allows this hand here to be really hard, but then to be, oh, so soft and gentle, okay? Because I am recruiting small motor units first, few muscle fibers first, okay? So I can control how this muscle moves. Fast, violent, slower, more caring, I don't know, more gentle. Okay? So we recruit small motor units first, right? Now, as this thing starts to relax, okay, it relaxes and then there's another stimulus. And it's a little bit bigger, so I recruit more. And the stimulus gets a little bit bigger. And I recruit more until I max out the voltage. I max out how big the voltage is to get the muscle to move. Okay. And you can kind of see down here, motor unit 2, and then motor unit 3, very large. I'm getting more and more of these. Okay. So above a certain voltage, all the units are recruited. Okay. And it doesn't matter. You can see I've got to 6 and I had max contraction. I went up to 7 and it didn't go any higher because I had already engaged them all. So max contraction doesn't get any more maxer. The impulses, the nerve impulses that come in to tell this muscle to contract can be summed up. Okay. This is referred to as wave summation. Sometimes it's referred to as temporal summation because of this, right? So if here is, this is my, okay, this is my muscle, okay, muscle, and this is the axon, this is the nerve right here, okay, that's the nerve, N is nerve, right? So if I have, change my color here. So if I have an impulse coming down in here, okay, all the magic happens, calcium gets inside, we cause contraction. Another one comes right after it. And then another one, I'll just do one more color here just to kind of prove a point. And then another one comes down right behind it. And it continues to stimulate this muscle. Okay, so I can continue to stimulate more and more motor units. This again is referred to as wave summation, okay, or temporal summation because they are coming down in time. What's that time? A few milliseconds, right? Because this is going to have some similar phenomena that's happening along here. Sodium voltage gated channels open, then potassium voltage gated channels open, and everything resets and it does it again. Okay. When they are coming one right after the other, right, relaxation is not complete. Okay, I contract and it completely relaxes. It doesn't do that. Okay, I don't get contraction all the way down to relaxation. Okay, we don't get that. Right? Here's a stimulus. It starts to relax and come on back down. And then another stimulus came. And I got more contraction. This is wave summation. I am triggering more and more motor units. Okay? So we're adding up all of those nerve impulses that are stimulating this muscle to contract. And I trigger, or I stimulate, I guess I should say, more motor units, which helps me to stimulate more muscle fibers. So here you can see there is a little bit of relaxation, but it doesn't go away. A little bit of relaxation, right? But it doesn't go to complete relaxation. A little bit of relaxation, and then boom, I can open back up. And it got the and a little bit of, and then boom. And then here you can see the periods start to get shorter and shorter. Okay? The time between these gets shorter and shorter and shorter. Calcium is not allowed to be completely re-upped back into the sarcoplasmic reticulum and the cisternae. Okay. Now, tetany is not tetanus. Okay, tetanus is that bacterial toxin that causes you to go. Okay, tetany is just something that happens. How do you know? Boom! Just sit there and hold it. Hold it. Keep holding it. Keep holding it. Keep holding it. Right. That is what incomplete tetany and tetany is. Right. It's what allows the muscle to get to peak contraction, okay, and hold that peak contraction for as long as you can until you reach this thing called, I'm tired, fatigue. Okay. And usually it's due to lack of, enough ATP to maintain that level of contraction. And that's what we talk about here. Those wave summations, again, those contractile forces add up because I'm engaging more and more motor units. More motor units, more muscle fibers, ta-da, magic. Okay. High enough frequency, again, tetany, no relaxation at all. Okay. Incomplete tetany has a little bit of relaxation, but not true relaxation. Okay. And again, calcium is able to stay in the sarcoplasm, and we just add more calcium and more calcium to the sarcoplasm. Okay. So we can keep engaging muscle fibers, actin and myosin interacting with one another. So this is really what we talk about. Okay. We can take that individual muscle twitch, that individual muscle fiber, and apply it to the whole. And that whole is motor units. Okay. With wave summation, engaging more motor units, more muscle fibers, and that way I can increase the strength of the contraction. Okay. I could be really gentle or I could be really violent with it.